This assessment asks us to predict the product of the reaction sequence shown on screen. And so we're going to start with this amide, react it with sulfuric acid, then thionyl chloride, and then do a reduction. Now, in terms of strategy for problems like this, I want to think for a second. Let's pretend we don't know this first step. Let's pretend that we don't know how the amide is going to react with sulfuric acid and water. Maybe we're on an exam and we just go blank. We forget that reaction. It's as if we've never seen it. But maybe a reaction we really know well is the reaction of thionyl chloride, right? So this reagent, SOCl2 or thionyl chloride. We know that we've only seen that reaction, that molecule, that reagent do two things in organic chemistry: convert alcohols to alkyl halides, or convert carboxylic acids to acid chlorides. So we know then, since we're already at the oxidation state of a carboxylic acid, if thionyl chloride is going to react with something in this next reaction, the product of this first step must be a carboxylic acid. And the reason we know it must be a carboxylic acid is because for thionyl chloride to react with something, especially in this chapter, that's probably what it forms. Now, good news, if we had remembered that sulfuric acid and water plus heat converts amide to carboxylic acids, we end up at the same place. I only did it that way to show you that for these multi-step syntheses, you always worry about, well, what if I forget one step? Well, as long as you know the one before it and the one after it, you can have a pretty good idea of what that middle molecule must be. We know that this probably needed to be a sulfuric acid, because our next step is going to be to react with thionyl chloride. So step one, sulfuric acid, water, and heat gives us the carboxylic acid. Carboxylic acids with an acid chloride, or with thionyl chloride, gives us an acid chloride. And now we're left for this reduction in step three. This particular molecule only has a single hydride that can give up, and it's a relatively weak reducing agent. And so it's only going to add one hydride to the carboxylic acid so that we can get an aldehyde as our product. The idea, again, of using that particular reducing agent is that it only delivers one source of H-, and it's not super reactive. So it's not reactive enough to reduce the aldehyde in the presence of the acid chloride. And so we end up with this as the product of our three-step reaction sequence. As I've said before, feel free to subscribe to the channel, like this video, like all the videos. I guess that's it. I hope by now you probably liked them all already. So I'll shut up. Let's move on to the next video.